Hi guys, so for the rest of this week we're going to work on industrial chemistry, so this is our option topic. The chapters for this can be found in the workbook. They're at the back of the workbook starting on page 77, so they're not in the textbook. We're going to do option 1, which is industrial chemistry and atmospheric chemistry. So the first thing you need to know is about the contribution of chemistry to society. They don't ask you this, but it's just knowing that chemistry provides us with pharmaceuticals, fuels, plastics, semiconductors, and also they like you to mention, if you were asked this, that it provides stable, well-paid employment in our country here in Ireland. It's a big industry in Ireland. James Musprat is known as the father of modern chemistry. Again, you don't need to know anything about him. He's Irish, and I think that's why they mention him in the book. The principles of industrial chemistry. So that's what we're getting into now, and this is basically what the whole chapter is about. Is understanding how the chemical industry makes money by carrying out chemical processes, basically. So there's just lots of definitions here. Again, not things that you necessarily need to learn off. Hopefully most of them will kind of make sense, that the word will match up with the definition and it would kind of be common sense. The first one isn't. Batch processing is a way of producing industrial substances. It's where the reactants, which we call feedstock in industry, are allowed to react for a fixed time with each other inside a vessel under controlled conditions, and when the reaction is complete, the product is isolated. So this is basically, you put all the reactants in the beginning and you take your product out at the end. I'll come back to feedstock, or no, I'll do feedstock now. Just to point it out, feedstock is the reactant. There's no difference between a reactant and a feedstock. The only thing I would say is that don't confuse feedstock with raw material. Raw material is what you use to produce the feedstock. You might have to treat raw material to make it pure to then use it as a reactant. So that's the difference between those two. So batch process, now we're going to go on to the other types of processes, which are the continuous processes. So batch process, you put your reactant in the beginning, you let the reaction happen, and you take your product out at the end. A continuous process is where you're constantly feeding reactant in to the reaction vessel, and at the other end you're constantly taking product out as it's produced. So you're not waiting for all of the product to turn, or for all of the reactant to turn into product. You're taking out the bit of product that's made, so you're making space in the reaction vessel that you can feed in new reactant, and so that it keeps going continuously the whole time. Batch is like making a batch of cookies or something in baking, that you're mixing up your ingredients, putting them in the oven, and you get a batch of cookies out. Continuous is that you're constantly adding more reactant and taking the product out at the same time. A semi-continuous process is a mixture of both of them. Not as important, I haven't seen them ask about this, but it's basically the first stage is a batch process where you make the product, and then the second stage involves the continuous process where the product is purified using the feed from the batch reactor. So you have your batch process in the beginning, and then as you get your product from that, you feed your product in, effectively becoming the new reactant in the next vessel, and you have a continuous process of purification there. The continuous process then, the advantages and disadvantages of that. So your first advantage is that it has low labor costs because it's all computer automated, but that does mean that you have the disadvantage of having higher capital costs, so higher costs in the beginning to buy all of this computer equipment and to set up the plant to be automated. Second advantage is that there's low risk of contamination because you're only making one product continuously. But the flip side of that, the disadvantage, is that there's less flexibility as the plant is tailor-made for one specific reaction to occur. The third advantage is that you can have long periods of the machinery being in use without needing to stop for maintenance. But that does mean that it's not as cost effective unless it's run at full capacity all the time. It's very expensive to have it just sitting there not doing what it's supposed to do. So you do need to know the advantages and disadvantages of batch and continuous, and you need to be able to compare them. The one we're going to look at is continuous, so I would say that that one's slightly more important. Okay, so the characteristics, these are your list of definitions that you need to know. The first one that I've done here, raw materials, that's not necessarily, that's not a characteristic, but I wanted to put it in just so you'd have the definition. So again, raw materials are used to produce the feedstock, and our feedstock on page 79 of your workbook, if you want to read along there, your feedstock is the first important characteristic. So the feedstock is the material used in the process to make the industrial product. It's the reactant. The second characteristic is rate. We want the best conditions of temperature, pressure, and the use of a catalyst to achieve the optimum rate and run the plant economically. We saw this in the equilibrium chapter, that you can't always have the exact temperature you want and the exact pressure you want. A lot of the time that's due to cost. And the compromises that we make on rate usually involve a compromise with product yield. And that's our next definition. Product yield, the conditions must be must ensure a reasonable yield in a reasonable time at a reasonable cost. And so that's in order to produce the amount that is economically beneficial, you do need to compromise with optimum rate. You need to find the balance there of how can you afford to heat substances up to a really high temperature or have them at a really high pressure, and also get out enough product that you're going to make enough money to be profiting rather than working at a loss. Your co-products, as you might, hopefully this is one of those ones that you will be able to come up with a definition on your own just from common sense. Co-products are products made along with the main product. So they're not unexpected because we will see them in the balanced equation for the reaction. So it's not that they're things that we didn't want to happen. They're just being produced alongside our main product. We know they're going to be there. We're expecting it. The flip side of that is byproducts. These are products made from a side reaction that is unexpected or unwanted. We didn't want that reaction to happen. And that, of course, then is going to reduce the yield of the main product. If there's a side reaction happening that we didn't want to happen, that's obviously happening because it's using up reactant. The next characteristic is waste disposal and effluent control. So the product must be separated from the co-products and byproducts. And so our co-products and byproducts are usually the waste. They mean, depending on the material that is being produced, the co-product and the byproduct, they may be harmful to the environment or they may be toxic. And that might mean, or that would mean, that they would need to be treated before they're disposed of, because we can't dispose anything into the environment that will harm it or the people around. And so this may add cost to our production. Some co-products and byproducts, however, might be useful and they can be sold on for profit then as well. So co-products and byproducts are not always a bad thing, but it's not the main product that we're looking for. Quality control, so obviously the quality of any chemicals being produced is extremely important, and that goes back as far as the reactants that you use. So the quality of your feedstock, remember feedstock is just another word for reactants. So the quality of your feedstock is very important, and the product is very important, the quality of what you're producing. So they are constantly going to be monitored to ensure that the product meets the required specifications, that it's pure enough, and that there are no other products mixed in with it. For that, you're going to have to use instrumentation, usually a type of chromatography called gas chromatography, and infrared spectroscopy. And that's just a machine down in the corner there that you might see. So the next characteristic is safety. And obviously your safety in the chemical industry is really important, because if you have a small accident, that can have huge consequences. So the priority there is to have all aspects of health and safety covered by legislation. And how they do that is they have ongoing health and safety training for staff, and you will always have personal protective equipment. There will be helmets, boots, goggles, earplugs, and protective clothing. The next characteristic is cost. So we have two types of cost. We have fixed cost first, and these are costs that must be paid regardless of the rate of production of the plant. So regardless of how the plant is doing, how much product you're producing, how much waste you have to get rid of, anything like that, the fixed costs are the things you have to pay regardless. That would be labor. You have to pay the people that are working. Plant depreciation, so that means that if if you need to upkeep the plant, you need to keep the plant in good working order. You need to repay any loans, anything along those lines. Those are fixed costs, things that have to be paid regardless of how much money your business is making or losing. Variable costs, these depend directly on the rate of production of the plant, of how well the plant is doing. So those are things like the costs of raw material, because if you're buying more raw material, you might be buying it in bulk, so you might get a better price for it. So that cost can change. It can also change depending on the market. The cost of effluent treatment and disposal, that's variable depending on how much you produce. Distribution costs can change, so the cost of fuel, if you're distributing them by rail or boat or in trucks on the road. Plant maintenance, you can have different costs cropping up there. So you might have something happen that wouldn't be a routine plant depreciation thing, and you could have an unexpected cost there. So that would be variable. And administration is a variable cost as well. So a question that comes up here is that they might say, are labor costs, are they fixed or variable costs? Things like that. Ways to reduce the cost would be by recycling feedstock. So if all of your reactant isn't used up in the reaction, recycle it, use it again. Using catalysts that can speed up your reaction so that you have less time constraints. And also reusing the catalyst. So we know catalysts are remain at the end of the reaction. Reuse them until they're no longer useful. So they will degrade over time, like any chemical would. You can sell co-products and byproducts to make a profit. We mentioned that a while ago. By optimizing your rate, so instead of having the highest temperature, that's the best temperature for a reaction, you might lower the temperature to bring that. Oh, sorry, I went forward too quickly there. We're just talking there about optimizing all the aspects of the running of your plant to reduce cost. The next characteristic is site location. So you want to make sure that when you're building your plant, it's on good networks for transport, whether that's by road, rail, or by sea. For international transport, you need to, usually these plants, you'll find them by a big waterway, and that's so that they have a large supply of water that they can take into the plant to cool things down. You need to be near a skilled workforce, so they're not going to be in the middle of the Sahara Desert. There should be scope for expansion for most industries, so that they have enough space around them, a big enough site that they can build on to the plant if needed in the future. You want to be in a country or a particular area in a country that has availability of the raw materials, so that you can purify them to get your feedstock. Obviously, you don't want to have huge costs. If if your raw materials are located in China, there's no point in building a plant in Galway, is there? You know, you'll have huge cost getting the material to Galway. And they need to be somewhere where there's facilities for disposal of their waste. The last characteristic that we need to look at is the plant construction materials. Obviously, it's really important that any materials that are used to build the reaction vessels, they need to be very unreactive, so that they're not going to react with the feedstock, the products, solvents or catalysts used. That's the point in grey underneath. And they need to be resistant to corrosion. That's a really, really big one. As well. For this reason, glass lined or stainless steel components are used. So you'll have stainless steel components a lot of the time, and some components that you'll have might be lined with glass on the inside. That question does come up as well. They'll ask you, why is glass or stainless steel used? And the reason is to prevent corrosion and that they're unreactive materials. So then the next part of this chapter is that we are on to the case study. So there's 3 case studies in the book. We're going to do the first one. You only have to do one. And the reason I've picked this one for us to do is because we've seen it briefly in the equilibrium chapter already. It's the manufacture of ammonia, which I spelled completely wrong there, up in the title. I'll fix that. And urea. So it's the manufacture of ammonia and urea, and that's done by the company IFI down in Cove. So the uses of ammonia that you need to know, it's used to make fertilizers, nitric acid and nylon, and it's also used as a lab chemical. That's a use as well. How it's made: nitrogen and hydrogen gases are reacted together by passing them over a catalyst, and you do need to know that the catalyst used is iron. So the 2 gases are going to be put into a vessel. There's going to be iron catalysts there to help the reaction occur to get your ammonia out. This flow chart here, which you can find on page 80 of your book, I've copied it from there, summarizes the main stages. So you have nitrogen from air. So we're going to be going on to how to get nitrogen from air in the next chapter. It's fractional distillation again, but instead of for fuel, it's for air. And hydrogen can be gotten from natural gas. So the gases are mixed together. You can see it's in a 1:3 ratio. They're going to be purified, and they're going to be compressed to 200 atmospheres of pressure. You need to know the conditions: 200 atmospheres of pressure, and they're heated to 500 degrees Celsius. You need to know those numbers. So the gases are then passed over the iron catalyst, and ammonia is formed. The ammonia will be removed here in this pipe, and any nitrogen and hydrogen that didn't react will go back up into the reaction vessel here. So that's why this is continuous. We're continuously going to be adding in more nitrogen and hydrogen. We're continuously taking out any ammonia that's formed, and the reaction keeps going continuously. It rarely stops. So again, when we were on the equilibrium chapter, we talked about the pressure and temperature and why we use these temperatures. Le Chatelier's principle tells us that the maximum yield, because it's an exothermic reaction, that the maximum yield would be high pressure and low temperature. So high pressure, because we've got fewer molecules on the right hand side. So, and pressure depends on the amount of molecules. There's 4 molecules here, 2 molecules here. So increasing the pressure will cause the equilibrium to shift to the right. So that would give us more product. And a low temperature because of it being exothermic. Sorry, I was reading something there and I stopped talking for a second. So a low temperature would be better. The reason for that is that because it's exothermic, heat is a product, and so if we lower the temperature, we're taking away product. The reaction or the equilibrium will shift in the forward direction to try to replace some of that heat, so we'll be producing more heat, but that will also produce more ammonia. However, we use a compromised pressure of 200 atmospheres and a compromised temperature of 500 degrees Celsius. And the main reason for that is the cost. If we had a very, very high pressure, the cost of building the plant and maintaining it would be extortionately high, and the same for the temperature. The manufacture of ammonia and urea. So onto the second part is the synthesis of urea. The importance of urea is that it's an excellent fertilizer because it has over 46% nitrogen in composition. Ammonia is reacted with, so there's 2 steps in this. Ammonia is reacted with carbon dioxide and it forms an intermediate, ammonium carbamate. I haven't misspelled that, that's the name of it. And then this intermediate, the ammonium carbamate, loses water, dehydration reaction, loses water to form urea. The overall reaction, you could just write the 2NH3 plus CO2 to give you the urea and water. That's your overall reaction. You don't need to know much more about the synthesis of urea other than the equations, to be honest. This is I've just drawn it, I haven't drawn it, I've just stuck in an image there of the structure of urea just for you to know what it looks like. So for the case study, the main thing you need to be able to do is apply these 10 characteristics that we talked about a while ago to the Haber process, the manufacture of ammonia, and to the synthesis of urea. So these 10 characteristics are summarized here for you. However, I really want you to go and read through pages 80 to 82 where this is in your workbook, so that you understand these. Don't just use this as your notes, even though this is what you need. I want you to understand it and get back to me with any questions. We're going through it quite quickly and I'm putting the onus on you to go and do it yourselves. But do get back to me. That's why I'm here during the classes, so that I can help you out with anything you need. So to take notes, you need notes on the contribution of chemistry to society. You need the processes batch, continuous and semi-continuous, and compare the disadvantages and advantages of them. The 10 characteristics of industrial chemical processes, those are very important. Those are your feedstock rate, product yield, etc. Then I want you to go over pages 80 to 82, like I said, on the manufacture of ammonia and urea, our case study. And just for that, the equations that you need to learn off, you have to learn off these equations. So they're there in the book as you read through pages 80 to 82 as well. So it's very important to include those in your notes. They're not in the summary on the last slide. And then the questions that you will have to do are outlined here. And that's the end of the chapter.